Hi everyone, welcome to this new video. Today I'll be making this guide for web developers who wants to get into game development. So I'm assuming that you're someone who has familiarity with the web stack, so TypeScript, JavaScript, etc. And maybe you're looking into making games, so getting into game development as a hobby or something you do on the side. And today, in this video, I'll present the various technologies you can use that leverage your knowledge, your existing knowledge and skill to make games. So this video is not going to present Unity, Godot, or Unreal. It's not also going to talk about game engines that are that uses JavaScript but are in an editor or something like that that you have to drag around with the UI. It's really about tools, libraries, frameworks that you can use in your already existing environment. So you will feel right at home in a sense compared to your web dev job. So the first option, let's first start with 3D. So for 3D on the web, you can use Three.js to make games. Three.js is a library that is not only used for games, but also for general web applications so that you leverage 3D experiences. But you can use it for games, and it's the most popular of the two options we're going to cover. So the Three.js was the first one, and Babylon.js is the second one. So here again, you need to realize that you will never achieve AAA graphics with something like Three.js, but I think you still have enough leverage to make something really good. So if you're careful with your style, etc., you could really pull off something very good. So this is the Three.js website examples. You can see like certain scenes, etc. Now to learn, if you're interested in learning Three.js, I have a resource to recommend you. So this is a playlist of how to build a Minecraft clone in JavaScript with Three.js. It's made by Dan Greenheck, and I will put the link in the description if you're interested in diving into Three.js. I might do it as well on my channel at some point, but for now I have other priorities, other things I want to tackle, mostly in 2D game dev. But this series looks like a really great investment. And one thing I want to mention is that, as I said, web game development, so 3D games in the web are limited in a sense compared to the AAA counterparts, but you can still achieve great things. An example of a style you could go with is use 3D for environments and 2D sprites. So you'll have this HD 2D style that is in vogue right now that you could tackle. And one software I would like to present is Blockbench. So if you don't have any experience with 3D modeling, Blockbench is a web-based application, but can be downloaded as a desktop app to make low poly 3D models, like the one you see here. And then you can draw your textures as pixel art and stuff like that. So this is what I would recommend you dive into instead of using something like Blender. I think this is much approachable and much more approachable. And if I were to go into 3D game dev using the web stack, so using JavaScript, TypeScript, etc., I think I would go with a Pokemon Diamond, Platinum, etc., that kind of DS style game where the sprites of the characters are in 2D, but the environments are in 3D and the perspective is top down. Alright, now that we have covered this option, so Three.js has the most amount of tutorials and resources online, there's another one which is less known but seems to be very powerful. It's Babylon.js. So Babylon.js is the other option you have here. It's more geared towards games. So you have your, I think, a physics engine integrated, while with Three.js you have to figure that out on your own. And regarding examples, I were able to find that Minecraft Classic was made with it, the web version. So here it is. So the issue with Babylon.js is really the lack of resources, but also all the impressive games made with it, like this Minecraft Classic by Mojang, so it's official, is really old. So it's more than 10 years ago. I went online and found out that Ubisoft did an Assassin's Creed game on the web with Babylon.js, but it's no longer online. And so that's another example, but it dates back to 2012, so really more than 10 years ago. So yeah, if I were you, I'm personally not going to use Babylon.js. I think I would rather use Three.js, even though it's less convenient in a sense, but I really like the fact that we have a lot of resources and it can be used outside of Gamedev. However, if you still want to dive into Babylon.js, I have this series to recommend, this tutorial, sorry, not a series, by Wael Yasmina, and you can find this in the description. So I will put the links to the resources in the description so that you can easily access them. Now that's it for 2D game dev, 3D game dev, sorry. Now let's go over 2D game dev. So for 2D game dev, there is the Phaser game framework. So Phaser is very well known. I think it's the most popular framework, JavaScript framework for making games in JavaScript and TypeScript. And here it is. And two games that are popular that were made with it are Vampire Survivors, the initial version, because it was later ported to Unity. I think it was due to performance reason, not on desktop, but on mobile devices. And the second game is PokeRog, which is a Pokemon roguelike game that is available on the web and went viral by a lot of YouTubers who played that game. And yeah, so it gained a lot of popularity. So what do I think about Phaser is that it's stable, and the documentation was kind of not intuitive initially, but they revamped everything, their websites, etc. And that means that the docs sites are much better. So if I go here to resources, documentation, everything is nicely organized. Maybe let me remove that. And yeah, so, and you even have an Ask AI that you can ask to pull you certain things from the documentation. Now, personally, Phaser uses object-oriented programming. That's the style. So you create classes for everything, for sprite, game objects, etc. It's not a style I prefer, and that's why I do not really use Phaser. I use another library that I will present in a moment. So now the other library I want to present. So if you want something stable, by the way, before we move on, if you want something stable, something that is proven to have made successful games with, then Phaser is a choice, a good choice. Now, if you want to learn about Phaser, you can use the resources on the website, or you can watch Scott Westover, which is a channel that offers a lot of Phaser tutorials. So that's something to check out if you want to dive into Phaser. Now the other option is Excalibur.js. So from my understanding, Excalibur.js is a bit like Phaser, but it has a much more emphasis on TypeScript. So it's really TypeScript first, and the documentation is really nice and well organized. And there's a bunch of features as well. So first, plugins, support for tiled, etc. First, yeah, so a lot of features you can have. And you have a showcase section with some games and a sample section where you can see Jelly Jumper, a game that I use the same assets for a tutorial on my channel. So yeah, so you can dive into it, into into Excalibur if you want something that is more TypeScript first. And yeah, so TypeScript first, and you prefer the documentation. In terms of performance, I think it's relatively the same as Phaser. So you shouldn't have issues with Phaser really and Excalibur for many types of games, because Vampire Survivors, that was made with Phaser, used a lot of sprites on the screen and it worked well. By the way, you can still find the web version of Vampire Survivors online on itch.io, and you can play it and see it for yourself. It's the one made with Phaser. If you want to dive into Excalibur.js in terms of video content, I know Drew Conley has a channel where he did a video on Excalibur.js, and that's how I learned about the framework, that it existed in the first place. So here, these two videos could be something you want to watch. And I think he also has paid courses that you can dive into as well. Otherwise, it's the docs, so you can read the docs as well. Now the third one, the one that I actually use, is KAPLAY. So KAPLAY, as I explained in a previous video, why I use this library is that it really, the style of programming that is really closer to the way we write JavaScript on the front end. That means it's not object-oriented programming. The way it works is that it offers a component system, like a component system, where you have game objects and their components, and each component offered by KAPLAY has features out of the box that you want to use. For example, you can create a game object by using the add function and passing it an array of components. And for example, here, the two components would be sprite. Let me look at the playground. I've made a video explaining why I use in more detail, so I would recommend that you watch that. It's the video previously to this one. So here, if I just increase the font size, you can see this is how we create a game object. By using the sprite component, we have access to sprite methods that you can use, like playing animations, etc. By using the positional component, you can position your sprite, etc. There are many other components offered by KAPLAY. And this is really the powerful way of like KAPLAY, is that you assemble your game objects using those components, and then you can get a lot of functionality for free. And it really is liberating in the sense that it really allows you to structure your code however you'd like. So with Shezzor and Excalibur, it's more you have to follow this object-oriented way of programming, while with KAPLAY, you're free to do as you wish. So that's something to keep in mind. More details in the video previously, why I use this game library. It's called like that, the title of the video. You can watch this after this one if you want. And for content regarding KAPLAY, well, I've been producing most of it, so I have plenty of tutorials that use KAPLAY to make games. So feel free to watch any of them. If you don't know JavaScript, I recommend this one. If you know JavaScript already, you can watch either the crash course or make a Sonic Runner game, which will give you a practical project in 2 hours. And if you want to go even more advanced, you can watch how to make a 2D developer portfolio with React and JavaScript, which I use KAPLAY in this one as well. And how to integrate React with KAPLAY here as well. Now that we have done with 2D game libraries and frameworks, actually there are other libraries, but this time around we're going to cover things, a way to make games that doesn't come with a lot of for free. You have to build your own functionality. And the Canvas API is the default choice, where you can just display graphics where the Canvas API, no libraries to install, you have to hand code everything. It's a way of coding that will learn, you will learn a lot by doing something like that, but you will surely be slower than if you would use a library like KAPLAY, Shezzor, or even Excalibur. But the simplicity can be an advantage, and the control also. Now, for the Canvas API, you can't do things like shaders, etc. I don't think it uses WebGL. So yeah, you're pretty limited in that sense, but you can still make a lot. And for learning about the Canvas API, I recommend Shezzor's Dev Corner. Hope I got the name right. And he really has a lot of great content regarding this. And by the way, I watched his Street Fighter series in order to learn how to implement the camera system when I made my P5.js Pokemon tutorial. So I recommend giving him a watch. Chris Courses is also another channel that covers game dev in JavaScript using the vanilla HTML Canvas API. He's more popular, and yeah, so you can watch his tutorials as well. Now the next part is that if you want to have more power than the basic HTML Canvas API, you can use Pixi.js, which is a rendering library that uses WebGL. It's a wrapper on top of the raw WebGL that you can use to create 2D experiences. So you can make games with it, but you'll have to write your own collision logic, etc. Or import a physics library. We're going to cover that topic in an instant. So if I go to the playground, you can see examples. So maybe let's wait for it to load. You have a sprite here. Let's see what we have. Other collision detection. Example with collision detection. And then you can have things like that. So there are examples on how to implement any of that. So if you want more performance than using the basic HTML Canvas API, I would recommend going with Pixi.js. For learning about Pixi, you can use the docs, or you can watch this tutorial by Wael Yasmina as well, which teaches you how to use Pixi.js for beginners. Now, with the options covered, you don't have a physics system built in with either the HTML Canvas API or with Pixi.js, but you can import your own. And here are a few libraries you can use. There's Rapier, which is a 2D and 3D physics engine written in Rust, but it can be used from JavaScript like that. So that's an option. You can use Matter.js as well, which is the one I've personally used once. And you can use Planck.js. So I recommend you check all of these physics engine and see which one fits your needs. Now you can basically use React. So in terms of front-end libraries, you can use them to make games. You can use them to make the UI of a game. And I made a tutorial on my channel explaining how. But what I want to drive home is that you can use React reasonably well for any games that doesn't necessitate like collisions. So anything that is turn-based RPGs, basically. So dungeon crawlers, turn-based RPGs, those things can be very well made with React only, with no need for a canvas element at all. So if you want to deepen your skill in React, maybe that's a good project for you to try to make a RPG with it. A turn-based battle RPG or a dungeon crawler where you focus only on the battle system part. Now there is React Native, and for React Native it's a bit different because React Native renders to the actual native platform, and there is React Native Skia, which allows you to display like graphics in a performant manner. So I think you can actually make games that are more advanced than just using React. So for example, games with collisions where you move around the map, etc. It seems to be possible. There was someone who was working on a KAPLAY-like library, but in React Native, but I haven't heard from them since. It's on my Substack. By the way, I have a Substack where I write written tutorials, and here you can comment, and in that comment section there was someone working on something like that with React Native. So this is something I definitely want to check out and try. So making a game with React only, just to teach React on my channel for those who are unfamiliar with it, so that you can use that as the UI of your game or just for a turn-based RPG style game. And React Native as well, I want to try out the possibilities with it. Now it's fine to make web games, but maybe you want to make money, and there are some options that you can make money with on the web. But I would say most of the money is on Steam and platforms that download, where you can download the game and play it offline. So to wrap your JavaScript game in a desktop app, there is Electron that you can use, which is the most popular way of building desktop app with JavaScript and TypeScript. Now there is an issue I heard that in terms of like the Steam Deck, the controller wasn't detected immediately or something like that. So there is another option. It's called NW.js. It's much older. The reason I'm presenting this, it's going to be apparent in a moment, but it's used by a famous game that is on computers, on Steam, etc., and also on consoles. So I just want to present this, that it exists, and then later on I'm going to come back to it. Now the other desktop technology you can use is Tauri. Tauri allows you to make desktop app by using the native web view. There's one thing about Tauri, I'm not sure if it actually works well if you use a Steam Deck with it. So Steam Deck is the device, the portable device made by Valve, the company behind Steam. And it uses a Linux-based operating system. And my idea is that, my apprehension, I guess that's the term, is whenever or not a game that is packaged with Tauri that works on Windows will work on the Steam Deck. Because since Tauri uses the default web view of the operating system, what will happen if it runs through the Proton layer, which is the compatibility layer between the Linux-based Steam Deck OS and the Windows executable, because the games are supposed to work for Windows, but they're I don't want to dive into that, but I'm not sure if it actually works. I haven't tested it. I have never made a game on Steam yet, so that's maybe if someone tried, they can tell me their findings. Now, the advantage with Tauri is that not only you will be able to make desktop apps, but you that are lighter, because compared to Electron, which was the previous option, Electron, the issue with it is that it packages a whole Chromium instance every time, so in the executable. So that means that it's bloated in terms of size, but the advantage of that is that you're pretty much sure that all of your users will have the app display and render the same way. So this predictability gives you a peace of mind, and I think it might be worth the extra bloat, especially for a game where people are more willing to put up with more bloat in terms of the download size. And then finally, what happens if you want to make a JavaScript game and port it to mobile, put it on mobile? There is Capacitor.js, which allows you to wrap your JavaScript game inside of a native app. Not native, but it opens up a web view so that you can have it on Play Stores, etc. So the web view is the app in a sense. So that's I think the only option. The other one is Cordova, but Cordova is a bit old and deprecated, it seems. So Capacitor is the modern alternative. Now, what happens if you want to bring your game to console, your JavaScript game to console? Well, that's something that I previously thought wasn't possible, that you would have to first make a popular game and then maybe re-implement that game or pay a porting house to do it for you. But it seems that someone was able to pull it off, and it's the game Crosscode, which is this game. It's really high quality in terms of graphics and things, and it really shows you that any kind of game is possible in JavaScript. This game was made in JavaScript and wrapped as a NW.js app. Now, the thing with it is that they had issues porting it to console, but they collaborated with a publisher called Deck13, which is their publisher, and they were able to port Crosscode to consoles using the HTML5 version. So it's not they didn't rewrite, they actually used it. They created their own interpreter which translates the code but is locked up in a cage. So let me read just this part. Okay, Crosscode is written in HTML5, and that means that there is tons of JavaScript, and live compiling it in a Chromium browser is causing security issues on consoles and is forbidden on most platforms, as hackers could attack the hardware through that. So we've had to find a solution, which is basically an interpreter which translates the code but locks it up in a cage. That also means we had performance bottlenecks, as the code was read by the interpreter and then translated into something the console would understand and then read by the console. It is like watching a movie in a live stream. Yet we have it under control now. We are still ironing out the last issues, fixing some broken bosses and quests, which also have to be interpreted, which means the interpreter must be able to read them, etc. But we're getting there. So they were able to port their game to console in JavaScript while still remaining in JavaScript but having their own custom interpreter. Now, that would be one exception, I guess, and you could try to make a popular game and then contact Deck13 when it gets popular and try to reach a deal with them. But the same studio's game, so the one who made Crosscode, which is Radical Fish Games, are working on another project called Project Terra. And I think now the name has been revealed to being Alabaster Down. And it's a 2.5D game where you have 3D environments but 2D sprites, like you can see here. And it uses TypeScript. And if you look here, if I zoom in, you see at the top, it is written Project Terra 0.0.0-6 alpha NW.js. So it is wrapped on desktop using NW.js. And there must be a reason why they use that. So maybe it is more straightforward to use NW.js. It doesn't have the issue that Electron seemingly has with regard to controller support. Maybe it's fixed by now, but I didn't know about this issue. The way I learned about it was through someone who commented on my using React for game development, and they comment. Maybe I'll try to either put the comment here on the screen if I am able to find it. So now someone asked, actually it was me, before I deleted my Twitter account and then reopened it later on. And I asked if it was using a web stack using JavaScript types or TypeScript, and the co-founder of Radical Fish Game responded to me with, yes, it's written in TypeScript. So that confirms that even their next game is using TypeScript. And you know what? That means that they made it viable to use JavaScript and TypeScript to make games that are both on PC and will go also to console. Otherwise, it wouldn't have made sense to make their second game using the same technology stack, only to find themselves stuck when it comes to porting to consoles. So that was something that I wanted to talk about. And that's the conclusion of the video. So making games with JavaScript and TypeScript is viable, at least for 2D, and even for 3D, as long as you don't push it too much. And that's it. So if you enjoy JavaScript and TypeScript game dev related content like this video, or you want to see more, feel free to subscribe to my channel and like this video. And hopefully I will see you in another either tutorial or video talking about JavaScript /TypeScript game dev related content. See you. Bye.